Bismillahirrahmanirrahim. We will continue, inshallah, today with chapter 4. We would like to talk today about log equations. I really hope you focus here because I know I can't be particularly animated here as I like to be, but really focus if you can. Try to do the best in trying to outlining some of these rules. In the previous video, we talked about some basic log properties, and we learn how to convert um, exponential equations into logarithmic equations. Log base b to the exponent, free up the exponent x equals y. That's how we did this. So this is key, of course, that you have to be able to convert from an exponential equation to a logarithmic equation and back and forth. So that's very important. And then we talked about log base 10 is called the common log and just written as log without writing the base 10. And log base e, the special number 2.71818, etc., is written as natural log. It's log base is a natural log and is abbreviated like this. And then we talked about some basic log rules, and we suggested that log of a times b is log of a plus log of b. And then we said log of a over b equals log of a minus log of b. And I had also suggested that log of a to the exponent of b it's a b, that equals b times log of a. So the exponent comes up over to the front. And finally, log base b of a, you can convert that into log of a over log of b. We shall need these today in order to solve log equations. So all of this started, if you recall, from our inability to solve equations like this, because it's easy enough to do solve this equation, 2 to what exponent equals 4. And this x was, we realized, was 2. And then I said if 2 to what exponent equals 8, and that's also readily intuitive, 2 to the third power is equal to 8. But then we have something like this, 2 to what power is equal to 7. That's not as easy to solve. And then we use logarithms to solve these equations. So how do we solve this? There are in fact two ways to solve this. One way is by converting this exponential form to a logarithmic form, which is the first thing we should do. So let's convert this log, okay, base is 2, okay, to the exponent is x. So remember, logarithms, they free up the exponent to the exponent x equals 7, like this. Okay, so we have converted the this equation from an exponential form, to a logarithmic form. Now here, if your calculator is able to do that, you can plug that in the calculator. So here I'm trying. See here, I can put in the log in this example, base 2 of 7. So base is 2 and 7. And that gives me 2.8073 approximately. So x is approximately 2.8073. Correct? Now, if your calculator does not have this, right? So all you have to do is you plug in the base and the number here in the calculator. It will give you the answer, x equals to be that. Now, let's say if you could not do that in your calculator, you could convert this like this. Okay, this is log of 7 over log of 2, because this becomes this. See, because we know log of base b of a is log of a over log of b. So you can rewrite this as this. Okay, so then you can solve this. Okay, so let me do it over here. So this is log. So log of 7 divided by log of 2. And again, the answer is the same. Okay. If your calculator has this, you can just do that. Or if not, you can just take log of 7 divided by log of 2. So look. So we had this equation 2 to the 7, 2 to the power x equals 7. We solved this by changing this into a logarithmic equation, and we got this answer 2.8, approximately 2.81, like that. Another way to solve the same equation, in fact, is like this. Okay. What you do is you take log of both sides. You take log of this, and you take log of that. So it's kind of like x squared equals 25, right? Then you can take the square root of both sides like this, right? It's very similar to that. So you can take the log of both sides. There's no law against that. So you take log of both sides like that. That's pretty good. And what's the benefit of that? Now that you've done that, so you can, I'm just going to rewrite this. If that's log of base 10 here of x equals log of 7. So I've done that. And then you can bring this x into the front, say, because we know this rule. Log of a to the exponent b equals b times log of a. So now you bring the x over here, and then you have log of 2 equals log of 7. Now to solve for x then, you just have to divide both sides by log of 2. That becomes log of 7 divided by log of 2. And this will give you the same answer, 2.81, that we got over here. Okay, so there were two ways to solve simple equations. First, by changing into a logarithmic form, and second, by taking logs of both sides. Okay, so we have learned two ways of solving this equation. So let's do some more examples. How about this? Let's just do another example of the same kind. 4 to the x equals 11. Now, here, I don't know, what should we do? Let's do it both ways. Why not? Let's just do it first, changing into log form. Log base 4, okay, free up the log base b to the exponent x equals 11. And then x equals, you can do that. Base is 4, and this is 11. 1.73 approximately. So we get this for x. Now what this means is 4 to the 1.73 equals 11. It's approximately because we rounded that off. So we converted this into logarithmic form. The other way of doing this is, of course, you take log of both sides, right? And then that allows you to bring this variable over here. So that becomes x times log of 4 equals log of 11. Divide both sides by log of 4, you get log of 11 over log of 4, and that will give you the same answer, 1.73. Okay, that was easy enough. So that's the basic logarithmic equation. Now, I like to go through some other different types of equations. Now look at this one. 2 to the x equals 2 to the x, 2x minus 5. Okay, let me try to write that neatly here. 2x minus 5. Okay, now this is an interesting equation. This is saying 2 to this is equal to 2 to that. Well, intuitively and naturally, then if 2 to the 3 equals 2 to the 3, that's the only way it can be that the exponents are the same, right? If the bases are the same, the exponents have to be the same. So you can just simplify this expression as x is equal to 2x minus 5. Just, right? And then you just solve for x. I subtract both sides, x from both sides, you get this. And add 5 to both sides, x is equal to 5. Okay, so this is easy enough, you say? Okay. So what we did here is that 2 to the some exponent equals 2 to whatever, 2x minus 5. We realized that if the bases are the same, then the exponents have to be the same. So we just did this. That's by virtue of the fact that the bases were the same. What if the bases are not the same, however? How about this? 2 to the x is equal to 4 to the x plus 3. Okay? Now, what if you say, well, maybe I could solve this by taking logs of both sides. Actually, you can do that. That will also work. Okay? And if you didn't know any better, and that will, if you do that, that's perfectly all right, and that will actually give you the right answer, which in the end is all that really matters. But if you realize here, the bases are not the same, but they're pretty equal, right? But because 2 to the x, you can rewrite this 4 as 2 squared, can't you? Right? 4 squared is just 2 squared. And then you can rewrite that as 2, and you can combine these, see, as 2 times x plus 3 like that. Because, okay, a to the m to the power n equals a to the m times n. That's why you can do that. So now we have what we have is now we have the bases that are the same, 2 and 2. If the bases are the same, then the exponents must be equal. So now we have x equals 2 times the quantity x plus 3. Let's distribute 2x plus 6, right? Bring the x here, right? And x is going to equal to negative 6 if I did the math correctly, right? So in this case, the bases were not same, but we made them the same, okay? And that worked out quite well for us. Now, let's do another example. Let's see, what do you think about this one? 9 to the 2x equals 27 to the x minus 1. Now here, you get the idea. Now here, the bases, both of them are, see, they are numbers, okay? So maybe I can do the same trick here, try to make the bases the same. Well, 9 won't go over here. 9 squared is 81. But 9 is 3 squared, isn't it? So I have 3 squared over here, which gives you 9 to the power of 2x equals 27 is 3 cubed, see? 3 cubed. 3 squared, 9, and 9 times 3. And 27. So, sorry. So it's, and then the exponent x minus 1. And then you can simplify this as 3. The exponent of 4x equals 3 to the exponent of 3 times x minus 1. Now the bases are the same. So you can rewrite as, I'm going to just distribute this over here. 3x minus 3. Take the 3x to this side, x equals negative 3. Okay, so these are two examples where the bases were not the same, but we manipulated the bases, so to speak, to make them the same, and we simplified the expression of the equation and to get the answer. Okay, so thus far we have solved equations such as this. Here we converted this into logarithmic equation. Log base 2 of x equals 7, or we took the log of both sides and solved it like that. Okay, so we solved those kind, and then we solved equations such as this. If we had the bases were the same, or if they were not the same, we manipulated them and made them into the same. Okay, here's another example. Let's see what you think about this. Log of base 5 of 4x minus 7 equals log of base 5 of x plus 5. Okay, so log of this equals log of that. Now what does that say? Well, if log of a number, see, log of 7 equals log of 7 means 7 equals 7, doesn't it? Right? So when there are logs on both sides like this, it's like the equation was like this, x minus, and then somebody decided to, just take the log of both sides. And they got that, right? So when there are logs on both sides like this, you can just simplify it and get rid of the logs. Now you have to be careful because there's nothing else attached. For example, there's no 2x or something. Then you can't just get rid of the logs because this term over here. But if there are is just one log over here and log over here, then this simplifies basically to 4x minus 7 equals x plus 5. Okay? Then you can just solve for x. Subtract x from both sides. You get 3x minus 7 equals 5. Add 7 to both sides. You get 3x equals 12. And then x equals 4. Like that. Okay? So this is another example where you just simplify the log equation. Okay, how about this one? Log base 4 of 5x minus 1 equals 3. This is a different type of equation that we have not seen yet. What do you think about this? How do we solve this? Well, this one you have to change this into exponential form. See? If you put this into exponential form, this is basis 4, 4 to the exponent 3, okay, equals 5x minus 1. Okay, right? So you take logarithmic form and you change it into exponential form. Okay? Now, 4 cubed is 16 times 4 is 64 equals 5x minus 1. Add 1 to both sides, you get 5x equals 65. And then x is equal to 12, 13. X is 13. Okay, so in this case, you change the logarithmic equation into a exponential form. One last type of example I'd like to do for you is this one. This log equation. Log of 2x plus log of x minus 5 equals 2. Now we are asked to solve for x, of course. All of these we are asked to solve for x. What do you think? We can't get rid of the logs. You can't just... And we can't take the log to the other side. Then you have still one term. And, well, ding, ding, ding. Ding, ding, ding. What do you think? Well, here, see, you have to appreciate this. Log of a times b equals log of a plus log of b. We have learned this rule. It was one of the log rules, right? So here we do the reverse of this. So given this, we can go backwards, right? So if you have this and this, right? That's a and b. So we can rewrite this as log of 2x times x minus 5 equals 2, right? So I rewrote this as log of, I combined these two. Now this is base 10. This is common log base 10. It's not written. Then you can write this as exponential form. Log base 10 to the exponent 2 equals all of that. 2x, excuse me, my pen is acting up, times x minus 5. Come on now. Like this. So it's 100 equals, let's distribute this. 2x squared minus 10x, right? Okay, well, I'm going to divide the whole thing by 2. That's going to be 50 equals x squared minus 5x. This is a quadratic equation. I'm going to rewrite this over here. 50 equals x squared minus 5x. I'm going to bring the 50 over here. And then get x squared minus 5x minus 50 equals 0. Well, there are 4 ways to solve quadratic equations. Graphing ain't going to do that. Factoring, completing the square, and a quadratic equation. Well, if push comes to shove, you can do the quadratic equation, which is this. Opposite of b plus or minus square root of b squared minus 4ac over 2a. But I think I can factor this. I'll give it a try anyways. So x and x. Two numbers that give me 50, and add or subtract to give me 5. 10 to 5 looks good. This is different. This says the signs are different. This was bigger when it's negative. Like this. So x equals 10 and x equals negative 5. Now you have to be careful here. Say you get 2 answers. Okay? Because one of them is a redundant answer. Yes, and I'll tell you which one it is. Is this one. The reason is because you can't take a log of a negative number, see? If I go in here, if I try to take a log, let me just get rid of this. I take a log of negative 10. See, it's undefined. You can't do it. You can't take a log of a negative number, because if I plug in negative 5 over here, I get log of negative 10. And that's haram. You can't do that and get log of negative 10. That's just not possible. So you always have to check your answers here, because you can't take a log of a negative number, and you can't take a log of a 0 either. Okay, it's not defined there. So this is not this is a redundant answer. It does not work. So the only answer here is x equals 10, and that does work. So these are some sample questions for logarithm. I just want to summarize the type of equations that we covered today. First was the basic log equations that started the whole story. We had 2 to the x equals 7. In this case, I changed it into a log form, or I took log of both sides and then solved it that way. Okay? And then I had an equation like this. 2 to the x equals 4 to the x plus 3. In this case, I made the equation so that the bases were the same. Like this. 2 to the square, right? And then I solved it by just equating those. And then I suggested that you have log of like this, 4x minus 7 equals log base 5 of x plus 5. And there are logs on both sides like this. You can just equate the two quantities here and then solve for x. Okay? And then I gave an example like this. In this case, we changed the logarithmic form to the exponential form, and then like this, we solved it. Okay, so we changed this into log base b exponent 3 equals 5x minus 1, and we solved it that way. And the final example I gave you was something like log of 2x plus log of x minus 5 equals to 2. And I changed this to log of 2x times x minus 5 equals 2. And then we changed this into the exponential form, and then we solved the equation in that way. Inshallah, next time we'll have an opportunity to do some more log equations. Until then, salatu wassalamu ala rasulillah. Alhamdulillah rabbil alamin. Assalamu alaikum.